Yes, sir. Okay.
Okay.
Now I welcome to Dr. Chandra Sekhar Pati Tripathi. He is the assistant professor in Department of Physics, Institute of Science, Banaras Hindu University, Varanasi. He his research interest for functional nanomaterials for sensing, catalyzing, and water treatment of wastewater treatment. Now I warm welcome to Dr. Chandra Sekhar Pati Tripathi sir for start a new session.
Thank you very much for the
Thank you.
introduction and warm welcome, sir. The reason I decided to talk about how technology is affecting environment, because the recent research I have done is mainly in the area of sensing, water treatment, and energy efficient devices. Okay, and in one or other way, they are basically affecting environment. So I thought it's a way to, from a point of view of material scientists, let's see that how technologies are affecting the environment and what new we are doing to uh, reduce that effect. Okay, so what actually I will do but before I switch to the green technologies. Okay, technology is such a wonderful thing. It has given us so many things. For each of our problem, there is a solution available. Okay. I mean, we are sitting at a distance of 1,000 kilometers and we are able to communicate, right? So it's because
Yes.
of technology. But what else this technology has done? Uh, like for example, you might have read in the news that the air in Delhi is so suffocating that it has become like impossible to stay over there. The schools were closed, offices, I mean, were closed, work from home was allowed. So this technology in some way has affected the environment. Okay, so but we need development. Okay, we cannot say that, okay, no, it's impossible. I mean, it's possible to live without development. So we need development, and for that we need technologies. Okay, but is it possible to have a technology which give us the development but doesn't harm our environment? Okay, so there comes the concept of green technologies. So what I will do in my lecture in next 1.5 hours or so, I will briefly talk about what this green technology is. What do we understand from this term? I will try to stay basic. I'll briefly tell you about the environment. Okay, like what do we really understand about the environment, and in what way this technology has affected our environment. Okay, I mean, what kind of pollution it has been brought. Okay, what are the things that has been like drastically changed over the a period of, let's say, 100 years or so. What is the concept of sustainable development? All the time we talk about sustainability. And then I will come to the work which partially I have done in this area, and some other works which has been done by some other researchers in that area in the field of green technology and environmental sustainability. Okay. So to begin, okay. So we understand from the word technology is the application of the knowledge or the science that we have for a practical purpose. Okay, it gives you something, it gives you a product. Okay, and what this green technology is, it's also known as environmental technology or clean technology. You apply this science. This can be environmental science. This can be green chemistry. I will talk in a bit. It can be environmental monitoring to produce something. So production is there, but it doesn't provide any kind of negative impact to our environment. Okay, just a second. I'm getting a Okay, so how can we use this technology? We produce what we need, but at the same time, we do not affect our environment in a negative way. Okay, so this green technology is not one term, it's like an umbrella of term, okay, which basically explains you that how technology is used, but there is a reduction of the impacts on the natural environment. Okay, so there are certain areas which are like important. Where should we start focusing on? So the first area where we plan, I mean, people are planning to focus, or actually they're working in that area, is the energy. Okay, most like one of the biggest issues related to environment is because of the use of these fossil fuels, the petrol and diesel, which has which has created like a tremendous amount of pollution. Okay, so is it possible to develop some alternative fuels? Okay, is it possible to develop some new kind of fuels which generate energy, which are efficient, but at the same time they provide less pollution? Okay, so that we can save the environment. Okay, there is a concept of green building. Okay, there is also a concept of producing things which are environmentally preferred. There is also a concept of green chemistry. Why? I mean, from where does the chemistry come? Because any product which is available in the market, okay, it's basically chemistry. So is it possible to design those products in a way which does the job, but at the same time it also eliminate the generation of the hazardous substance? So there are like some certain principles which should be followed if we are working in the area of green chemistry. There comes also the concept of nanotechnology. Okay, so basically what this nanoscience, nanotechnology is, that miniaturization of things. Okay, you go at the nanoscale and there you see some fascinating behaviors. Okay, like the same material which is of the millimeter size, it has certain kind of behavior, but if you could manage to prepare it at a nanoscale, all the properties, there is a very drastic change there. It shows some magnificent behaviors. Okay, so can we use this green nanotechnology? Okay, now nanotechnology has its own problems, so that's why there comes the concept of green nanotechnology. Okay, can we use this green nanotechnology? Can we use the concept of green chemistry? And can we produce the things which we are producing, which we need, but at the same time we do not harm our environment? So there are different types of green technology. The whole idea is you use technologies which are friendly to environment. Okay, so an environmental friendly is the key word. Actually, you produce less hazardous substance, you produce less pollution. Rather, your technique should be remediate and restore the environment. Okay, these techniques should be, there is a concept of monitoring and assessment technologies. Okay, there are prevention technologies. Okay, they prevent actually the pollution or the waste that we are basically throwing in our environment. Okay, it prevent those human activities which are damaging the environment. Okay, there are control technologies. Okay, so it's a very broad area. Okay, now it comes with certain goals. Okay, and these goals are briefly: you recycle, you reduce, you refuse, you renew, and there should be a response towards it. Okay, so what we can basically reduce, we can reduce the consumption of fuels, we can reduce the consumption of energy, we can basically reduce the production of waste. Okay, so the things which we can reduce. Okay, what we can recycle, so we can recycle paper, you can recycle bags, we can recycle battery, we can recycle clothes. You might have noticed the packets that we receive these days, there is a mention that okay, this bag has been prepared with some recycled paper. So reduction is like one of the goals, recycling is another goal, renewing. Okay, can we renew something? Okay, and in a bit we'll talk about renewable energy. Okay, so energy which can be renewed. The fossil fuels like the petrol and diesel that we use, I mean, these days in most of the things, they are not renewable. Okay, the fossil fuels has been prepared, let's say, over a period of thousands of years. Okay, and it's limited, they cannot renew it. Basically what will happen, at some point they will finish. So is it possible to have something which can be renewed? Okay, so there comes the concept of solar energy, there comes the concept of wind energy, there comes the concept of biofuel, there comes the concept of, like other kind of energies, okay, other means to produce energies, okay. So the concept of renewing, okay, responsibility is, it comes to us, okay. We should be a little more responsible, okay. We shouldn't start like throwing things, like for example, most of us has this habit of turning all the switches on and okay, leaving when we are leaving the room, okay. We forget to turn the things off, okay. So it's like we do not waste anything, we do not waste water, we do not waste electricity, we do not waste anything which we have in excess, okay, because somebody else on the other side of the earth might need that, okay. So these are some the basic goals of green technology. So the whole idea is okay, like the aim is of this green technology thing is to reduce waste, to cut pollution, to reduce the use of fuels, to use more of these alternative energies, to use things which in one way or other way are not harming our environments, okay. So these are the products which comes in the the, like the purview of the green technology product, okay. So okay, one more thing, we use a lot of things and we generate so much of waste, okay. So is it possible that we can take that waste and from that waste we can generate something useful? For example, uh, we use a lot of water, okay, and that water gets wasted, okay, it goes through some kind of drainage lines or some kind of sewers. So is it possible to take that wastewater and to convert it into clean water? Okay, that's one of the very important aspects, okay. Is it possible to produce something from the things that we do not use anymore, okay. So all these things they comes to the area of the green technology, okay. So it's like the products that we need in our daily lives, can we use can we prepare them by using some of the waste materials, okay. We'll discuss in a bit about the biofuels and you'll see that how this biomass can be used to generate the biofuels, okay. Now, so what are the benefits? So the most important thing is it doesn't do any harm to the environment, okay. That's the most important goal of this green technology. The environment should not be anything which is not harmful, okay. It's getting popular because it's more environmental conscious. Maintenance, well, it's a bit ambitious statement, but if we could manage to like bring these things in the market, and if people start using it, certainly the maintenance cost will be low. When we talk about the renewable energies, okay, so again the cost will be low because the sources are basically renewing themselves. We have a lot of water, we have a lot of sun, we have a lot of wind, so that can be used to generate energy, okay. But this will happen only if we implement it in a longer run and for like the maximum population, okay. And then you might have heard about these different kind of agreements which takes place between the different countries regarding the global warming and CO2 emissions. So all these techniques will further helpful in the reduction of the global warming, in the reduction of CO2 emissions, in the reduction of anything which is not good for our health purpose. Now, it's not like everything is just good about this green technology thing. There are also things which are disadvantageous. There are actually, rather than saying disadvantageous, I would rather say there are like many challenges before the application of this green technology thing. And what are those challenges? Briefly, the first is since the setup is not available, okay, so the initial investment is very high. Like for example, imagine we have cars which are running with petrol, there are cars which are running with diesels. But if you tomorrow you want to, I mean, we have now in the market the electric car, okay. There are companies in India, there are companies in US, they are producing these electric cars, okay. But not many people are buying. Why? Because you don't have fuel station, right? I mean, there are not so many charging stations available like petrol stations. So if let's say the government is planning to promote these kind of vehicles, they need to invest a lot of money in that. So the initial investment is very, very high. Okay, then people are not very familiar. Okay, there's always a resistance among us for any new things. There are very few people who appreciate the new technology coming to the market. Okay, price is one of the reasons. Okay, because everything which comes new is like really, really expensive, but it will take time. And by the time let's say 20 years down the lane, you will realize that the electric cars are of the same price as of the petrol car, or maybe cheaper also. Okay, the technology which needs to produce these things, like for example solar energy. Okay, you might have seen the solar panels like here and there, but it's still not that the profitable. Okay, so because the technology is still evolving, the research and development work is still going on. Okay, it will take time, because that's the thing about the science and technology, is that it takes time. But let's say in some years you'll find that okay, these solar panels are like they're everywhere, and they're producing much more electricity than we need. Okay, also, since things are new, human resources are very limited. There are very few people who are experienced with that kind of system. Okay, so these things are actually, you see, related to the time. The more these techniques will be used, the more the people start using, the more these things will come into the market. These problems will be resolved. Okay, there is another thing from the government side. The policies, they are very crucial. Okay, for anything uh, to happen, to go on a large scale, the government policies make a very important role. Okay, so in most of the countries there are not very final kind of policies for these green technology related products. Okay, but let's hope that in the near future things get resolved, and our environment, we get a better one actually to live with. Okay, I talked about green chemistry. Okay, so what basically this green chemistry is, it was the Environmental Protection Agency in the United States. They give a definition of green chemistry is that design of chemical products and processes to reduce or eliminate, so the reduction and elimination of the use and generation of hazardous substances. Okay, so the most important aspect of this green chemistry is the concept of design. Okay, you design something which is reducing, which is eliminating, and which is generating less and less hazardous substances. Okay, so there are like 12 principles of green chemistry. Actually, they're basically design rules to design new compounds, to design new, because everything is a chemical, right? So it has to be designed in, let's say, like all the drugs that we take, I mean, all the medicines. Okay, all the products that we use, they are in one or another way, there is a chemistry involved. Okay, so the green chemistry says, okay, there are 12 principles, and these 12 principles, they should be used to basically to make those products less hazardous, less dangerous to our health. Okay, so first is prevention, atomic economy, safer chemical synthesis, safer designing, safer solvents. They should be energy efficient, use of renewable raw materials. Okay, if we can use some renewable materials, there should be a reduction in derivative, catalysis, degradation products design, and can we generate some, let's say, real-time analysis for pollution prevention and the prevention of the accidents. Okay, I mean, these things, when you work in lab, I mean, these things happen. So is it like possible that we design our the new chemicals in these possibilities? Okay, so these are I will not go into very detail, but there are these principles. Okay, and together with this, because chemistry is related to design. Okay, and there comes also the concept of engineering. So there, and together with that, there comes the green engineering. Okay, so the green engineering is design, commercialization, and use of economically feasible processes and products while minimizing the pollution and any threat to human and the environment. Okay, so there comes the concept of green engineering. There also comes the concept of cleaner production, industrial ecology, and eco design. Okay, Even like green chemistry, there are 12 principles. There are also 12 principles of green engineering. Okay, so like for example, there should not be any unnecessary thing. Okay, there should be a multi-component products. There should be design and process should must include integration in with interconnectivity with available energies and materials and all. Okay, so there are certain principles which must be followed. Okay, you cannot say like, okay, all the chemistry is green chemistry. Okay, only chemistry which is following those rules. Okay, the engineering which is following these set of principles are basically falls in the area of the green engineering. Okay, and the product which comes out of it is basically will be fulfilling the goal of the green technology. Now, why we are talking about green engineering and green chemistry? If you look at this diagram, so it shows you the relation between the green engineering, the green chemistry, and how they basically affect the quality of our life, how they make sure that the development which is basically happening with these chemicals or with these these buildings, they are not harmful to the environment. Okay, so this diagram shows you that how green engineering and green chemistry is related to a sustainable environment. Okay, so the need of the hour is to use resources in an efficient manner, which are basically reducing the impact on the environment. Okay, and to get that done, we need modification in our engineering designing, and that's why these 12 principles that I just showed you about the green engineering, they are basically gaining importance. Okay, so in a brief, if we want a better environment to live with, if you want let's say a cleaner air, if you want clean water, then we need to design our work, we need to design everything that we do in the lab or in the industry by the principles of these green chemistry and green engineering. Okay, so that was brief about the green technology. I'll briefly talk about the environment. What actually do we understand about environment? And then I will move to the work related part. Okay. So it's basically, we are taught in our school that what do we understand by the environment. Okay, so the environment usually means the natural surrounding. Okay, anything which covers around us. Okay, and it was basically originated from a French word environ. Okay, which means to surround or to encircle. Okay, so if you go into the dictionary, there are also some dictionary meaning of environment. There are also some etymological meaning. Okay, there are also meanings of given by different people working in environmentalist and people those who have working in that area, like Simon Ball and Stuart Bell said that it's difficult to define, but normally it is basically related to our surrounding. Okay, so in a sense that environment now has become very kind of a vague kind of word. Okay, so air or space or waste, land, plant, everything comes under that umbrella. Okay, there are also definition from Encyclopedia Britannica that environment basically connotes the entire range of external influence acting on an organism, both the physical and biological, and other organism, that is forces of nature surrounding an individual. Okay, there are also E.J. Ross has defined environment, Herkovitz has defined environment, and Gilpin has defined environment. Justice P.N. Bhagwati, actually, he was a very popular judge. He said that the term environment, it refers to the condition within and around an organism which affects the behavior, growth, and development or life processes directly or indirectly. Okay, so it also includes the condition with which the organism impacts. Okay, and there are other people. Okay, the United States Councils, I would like to quote, says it says that man's total environmental system includes not only the biosphere but also his interaction with his natural and man-made surroundings. Okay, so this man-made surrounding is what we have made by using a lot of technologies and all. Okay, so just a second, I'm getting a call. sorry. So there are also some, the government definitions of environment. Okay, so the Environment Protection Act, it says that environment includes water, air, land, and the interrelationship which exists, among all these in human beings, other living creatures, plants, microorganism, and property. Okay, now you see, you look at this definition and you realize how bad our environment is. Okay, we do not have access to clean water. Okay, I think most of the houses are now equipped with an RO system. Okay, uh, the water that we get has a lot of fluoride, a lot of arsenic, a lot of mercury, and this and that, so many pollutants. Okay, you look at the air, how bad this air quality has been. I mean, Jaipur is still good. Okay, I was in Jaipur for like almost 5 years, and I realized that the air quality of Jaipur is still very good. Okay, but the moment you move from, let's say, Jaipur to Delhi, you will realize how bad this air quality is being. I mean, Delhi choked recently. Okay, and every year it happens in the starting of the winter season that the air quality of uh, Delhi goes, bad. We every year we listen about these air quality index, and we see how badly we are performing on those indicators. Okay, so even the water has gone bad, even the air has gone bad. Look at the land. Okay, what is happening to the land? Okay, with the use of so many pesticides, with the use of so many, chemicals, most of the lands are now having some, toxic elements in that. All the food that we receive uh, from those lands to us, okay, they have, one or more things which are not basically good for our health. Okay, so, by so we ran in a race of development, but what that development actually did, it we received that development at the cost of our environment. Okay, at the cost of our water, at the cost of air, at the cost of land, and basically this has destroyed the so-called the interrelationship between these two. Okay, and this is what makes the green technology an important concept. Okay, uh, basically this environment basically has two types of components: abiotic components and the biotic components. You might have read this in your school textbooks. Okay, uh, so the goal of the technology is now to address the pollution that we have created to our environment. Okay, so what kind of pollutions we have done? We have released some, unwanted materials to our atmosphere. Okay, which are something which we do not want to breathe, but it is available, it is there in the environment. Okay, uh, something which is in our water, because like as I said, like the presence of the excess of fluoride is there, the excess of arsenic is here, the excess of mercury is also in some part of the world. Okay, so we have basically produces a very harmful effect. Like for example, we see here, like we have this river Ganga over here, and we see that like all the waste, it directly goes to that river. Okay, there are some, treatment plants, but they are very few. Okay, otherwise, a lot of waste, it directly goes to the river, and basically what it is doing is, it is just, making that water dangerous, for the purpose of drinking. Okay, similarly, we are harming the quality of the soil by, as I said, by putting toxic elements, by putting a lot of pesticides, by putting a lot of fertilizers. Okay, and so on and so forth. Okay, and what all these activities of us are doing, they are basically producing dangerous effect to our health. Okay, you might have read that how, some kind of diseases have increased over a period of, certain years. It's good that, we have like increase in the medical facilities. It's good that there are so many new kind of treatments are available, but at the same time the diseases are also growing. Okay, you look at any hospital, it's just full with patients. So from where those diseases are coming? It's coming from here because we have a not so good environment in which we are living. Okay, what we are consuming, it has a lot of things which we shouldn't take actually. So this pollution actually, this polluted environment has produced a hell lot of, I would say, dangerous effect on human health. Okay, so this is it. There are also, like, some government definitions. that what is the environmental pollution, what are the hazardous substances, okay, what does this contamination mean. So what this goal of this green technology is, okay, is to bring a sustainable environment. Okay, what do I mean by sustainable environment? It means there should be a balance between the environmental protection and the social responsibility. Obviously it should not produce any negative effect on economy over time, okay, but there should be a balance, okay. And to create this balance, the green engineering and the green chemistry that we just discussed, there are certain principles, okay, so they play a very important role in creating this sustainability, okay. We can develop some chemicals, we can develop some products, we can develop different kind of systems which are environmentally preferable, which are energy and resource efficient, and at the same time cost effective, okay. So this environmental sustainability in one line is about making responsible decisions that will reduce our negative business impact on the environment, okay. And this is the need of the time, okay. So what is needed is to make a choice that respect the relationship between the three E's: economy, ecology, and equality, okay. There should be a balance, okay, because once this balance is gone, what we will have certain things in a very, let's say, on a very good way, but at the same time their repercussions, their effect will be very negative on the environment and other related things, okay. So our goal is to produce or to develop these technologies which are basically helping in to create a sustainable environment, okay. Okay, so this was a brief about what this green technology is, what are some basic concepts, and how those concepts, and what should be the goal of those concepts, okay? What should we do to produce actually less and less dangerous effect on our environment, okay? Now, what I will do in the next part of my talk is, since I'm basically a material scientist, I will briefly explain you that how we can use these, nano-sized materials, and how we use these, nano-sized materials in, let's say, I'll mainly talk about the wastewater treatment for some minutes, okay? So how we use, those nano-sized materials for the cleaning of water, okay? So as most of you are aware of, basically these nanoparticles are materials in the size of, some nanometers, okay? They have very unique physical and chemical properties, okay? And as I said in the very beginning, that when you go from bulk means like, millimeter size materials to nanometer size, then you find that, okay, their magnetic properties, their electrical properties, their mechanical properties, their optical properties, their chemical properties, their biological properties. So all these properties, they show like a tremendously different behavior, okay? And one of the reasons is there is a concept of surface to volume ratio, okay? You take a cube of 1 millimeter by 1 millimeter and you cut it into, let's say, cubes of 1 nanometer to 1 nanometer, you'll find that, the surface to volume ratio has increased, it has enhanced actually, okay? And that leads to, more active sites, and because of more active sites, there's higher reactivity, there are higher mobility and other related properties, okay? So, they're not new. These nano materials have been used in the past, but with the development of science, with the development of technologies, we are now able to design new materials. We are able to design materials with a purpose, okay? And we are now, we are able to understand, to characterize them, okay, to really understand what, these nanomaterials are made up of, okay, what are their like intrinsic properties, okay? And if I want to, let's say, design something for a particular purpose, what changes should be made, okay? So this technology has been extremely helpful in doing that, okay? And these nanoparticles, they have application in almost every area, okay? You use cosmetic products, it's being used in that one. You use food, it's used in that one. You use medicine, it's used in that one. You use agriculture, it's used in that one, okay? In food processing and preservations, it's used in food packaging. You know, we use nano coatings and all. In agriculture, pesticides, nano fertilizers, herbicides, and sensing, and for sensing also, like it's being used in medicine, like, you know, many antibacterial, antifungal, antiplasmodial, anti-inflammatory, anti-cancer, you know, many actually for many purpose it is being used. Okay. Nanomedicine is a very, you know, growing area, okay, where these nanoparticles are basically being used for targeted delivery and all. Okay. Together with that, like as I said, I'll briefly talk about the water treatment. They are also used in the uh, for treating, you know, various pollutants. Actually, I forgot to include a slide. There is a professor from IIT Madras, Professor T. Pradeep. He received Padma Shri this year. He has developed a water purifier, and what it does, actually, it removes arsenic from water. Okay. And that is now commercially available, and actually government of India has taken initiative, and that arsenic water purifier, its name is Amrit. You can Google it, Amrit water purifier by Professor T. Pradeep, and it is basically being used in different part of like West Bengal and other regions where this arsenic problem is a very, you know, there's very big problem of arsenic in water. Actually, it's a problem in the Ganga belt. Okay, so there it's being used. Okay, so there are like devices now available. Okay, which are basically with the help of these nanomaterials, they are basically being used for the treatment of the water. Okay. Okay, in 2019, the global market, just to give you an idea like how fast this market is growing, the global market of different nano products was more than 8 billion US dollars, okay, which is expected to show an annual growth rate of like around 13% by 2027. Okay, so it's like a really, really growing market. Okay, if you, I mean, some of you might be involved in, you know, in a research. Okay, so if you look at the literature, that how in, let's say, last 20 years, different kind of nanomaterials are kind of coming up with different kind of new properties, and a lot of research is going on. Okay, and at the same time, many people are also, you know, bringing products in the market. Okay, so there is a huge growth basically is taking place. Okay. This scheme shows you like how we can basically synthesize these nanomaterials. Okay, so there are three main methods. There are two different approaches for us: a top-down approach and bottom-down. Like either you can take, like, you know, very big blocks and you like you cut it, break it, and you go like to a really small one, or you take like some like the really smallest one and you make like a big one. So there are two approaches. There are three different strategies: first physical method, second chemical method, and third biological method. So in physical method, ball milling, thermal evaporation, ultrasonication, photoirradiation, laser ablation, spray pyrolysis. Those, you know, who are interested to know a bit more detailed, I mean, you can contact me later. Okay, but I don't want to go into very detail. Those who are familiar with chemistry, they know that like Sol-Gel process, by chemical reduction, by chemical vapor deposition, by servothermal, reverse micelle, and co-precipitation. These methods are known as chemical methods. There are also biological methods to produce these nanoparticles. Okay, you can use bacteria, fungi, algae, plants, viruses, and all to produce these nano-sized materials. Okay, they can be of different shapes, they can be of different sizes. There can be like, you know, different kind of functionalizations, so that we decide depending upon our use. Okay, like for what purpose we want to use it. Okay, and once you use any of these methods to produce your nanoparticles, you can, you know, look for your application, and as I said, like they find their application in a variety of areas. You can use them for agricultural productivity enhancement. Okay, as a either as a fertilizer, as a pesticide, or as a sensor. Okay, because it can also sense that if you have like anything extra in your crops. Okay, so you can develop sensor also. You can use these nanomaterials for air and water remediation, cosmetics. Well, one of the biggest markets, disease diagnosis, treatments, and drug delivery. They are being used very extensively. Nanoelectronics is growing. Okay, if you remember, looking at computers, let's say 10 years back. Okay, so how big the screens used to be, how big the CPU used to be, and then comes the transistor. Okay, when triode valves were replaced by the transistor. Okay, so everything became compact. Okay, we got these microelectronics industry, like there was a boom at one point of time. Okay, so everything became compact. Okay, the performance like become really fast. Okay, now we are going to the era of nanoelectronics, so we go from 10 to the power minus 6 to 10 to the power minus 9 meter. Okay, so things will become compact. Okay, at the same time the performance will increase by many factors. Okay, so electronics is an area where it is like getting like really importance. Energy storage and its production and conversion is one of the important aspect. Okay, where these nanomaterials are being used. Okay, you remember batteries. Now you look at these lithium-ion batteries in your mobile, sodium-ion batteries in your mobile. So these nanomaterials are also being used, to produce devices which can store energy, which can produce energy, and also which can convert. Okay, food packaging is also preservation and packaging is another area where this nanoparticles find a lot of applications and other related things. Okay, so they have a tremendous applications. Okay, the important thing is like when we work in this area, so you have to first thought about, okay, like what method you are going to use for these preparation, and then you have to go through like a lot of characterization to really understand what is basically the size of that nanomaterial, what is the shape of that nanomaterials. Okay, and what other properties, like, okay, if you shine with some light on it, what kind of effects it is showing. Okay, and depending upon that we do some modification, and then we try to find, okay, what kind of things it can be applied for. Okay, so this is just to give you, because now we are talking about green methods. Okay, so you can also do these things with some chemicals. Okay, but those chemicals can also be hazardous. I mean, they can produce like some bad effects to the environment. So there comes the concept of, so we synthesize this, so but we need these nanoparticles, right? Because they have so many applications. So is it possible to synthesize these nanomaterials through a method which is less harmful to the environment? Okay, and there comes the concept of these green synthesis. Okay, so the green synthesis is, okay, you take a plant, you take like a microorganism. Okay, and with that, because a plant is not harmful, right? So you take that plant, you take a microorganism, and with the help of that, you try to find out some extract from that one, and from that extract you synthesize your nanoparticles. Okay, and then you add some the surface functionalization thing, and then, like as I was saying, like you need to characterize these nanomaterials. So there are like a different range of tools available. There are like X-ray diffraction method, so that tells you about the the crystallinity of that material. Okay, you can do like for this FTIR, Fourier transform infrared spectroscopy, so that tells you like what kind of functional groups are attached to that material. Okay, you can do energy dispersive X-ray spectroscopy, you can do transmission and scanning electron microscopy, so they basically tells you about the morphology. Okay, you can see like, okay, what is the shape of the materials that I've synthesized. Okay, is it like a spherical, or is it like some cube, or is it like some kind of flower or something like that. Okay, you can do UV visual spectroscopy. Okay, so the first step is like you prepare like a synthesis method, you synthesize it. And then the second step is, once your synthesis is done, you have received your product, you go for characterization, you find out the properties, and then you aim your application. Okay, now it's not like everything is just good about these nanomaterials. Okay, there are also many challenges before it. Okay, so as I said in the past, like a lot of chemicals were being used, so they were producing these nanomaterials, but at the same time they were producing like some dangerous chemicals to the environment. Okay, a lot of waste was going to the environment, which was basically producing negative effects over there. Okay, and there comes the concept of green synthesis. But one of the biggest challenges before this research is the large scale productions, okay? Because there are two types of research. So a research which we do in our labs, we produce something, but we do not produce on a very large scale. We produce something to test the concept, okay? But if I want to use for a particular purpose, I need to produce that material on a, let's say, kilogram scale or maybe 100 kilograms, okay? So that research is still, very limited, okay? The concept is good, the testing is good, but the large scale production is still one of the area where many people are trying to work out, okay? For some kind of materials, it has been possible, but there are many types of new materials that has been developed, and their large scale synthesis is still a challenge before the researcher, okay? So people are basically using, okay? And then, optimization is another thing, okay? So scientists, they find it very challenging to optimize all the things, okay? So there are studies basically which are going on, okay? So scaling up and improvements, okay? Improvement in the yield, improvement is the stability, improvement in all the properties which are basically being shown by these materials is like one of the challenges before the scientific community, okay? Now I'll briefly, so I'll briefly talk about their application, like the kind of work which I am doing, okay? So you see like a picture on your screen. It's a scientist, his name is Richard E. Smalley, and he received a Nobel Prize in Chemistry in 1996, okay, with two others for the discovery of fullerene. Fullerene is one of a very important compound, okay? In 2004, the population of the world was like around 6.5 billion, okay? And by 2050, well, actually, this is said like many years ago, but I doubt even before 2050, we will be 10 billion people, okay? So he made an index that, okay, what would be the, top 10 problems before the humanity in the next 50 years, okay? And, you will be surprised to know that in his index, he put terrorism at 6th place, poverty at 5th place, environment at 4th place, which we are discussing. He put energy at the very first place, okay? That energy is going to be one of the biggest issues, biggest challenges, and water at the second places, okay? So these are the two areas actually where, that we are going to face most of our challenges in the near future, okay? If you remember in the very beginning, when I started talking about the green technologies, I said the energy is the first subject area, okay? Because most of the fossil fuels that we are basically using, at some point they will be gone, okay? So what will happen after that, okay? So energy is one. Water we have, I'll show you in a bit, but there are issues with water. So water he put at the second place, okay? So what actually is the current situation, okay? So we have a lot of water, but 97% of that water is in oceans, okay? So that, I mean, we cannot in principle use, okay? The rest of the 3% is basically trapped in ice and glaciers, okay? So only a very small portion of that water is available as fresh water, okay? So it's like 0.01%, okay? It's like really accessible, okay? So we have water. It's not like we don't have, but we cannot use it, okay? The water from ocean is like not useful at all, okay? So we have water, but we don't have water. We are in a situation like that, okay? So what else is happening? The population is growing, and with the growing population, there is a growing demand of water, okay? You might, I mean, I'm sure that you all watch news, and every year what we find in the news that in many parts of Maharashtra, even in some parts of Rajasthan, we see now these problems are also happening in the states where we used to have a lot of water, okay? I tell you the situation about my place. I remember like let's say 10-15 years back, we used to get water at 30-40 feet, okay? Now we need to go at least 150 feet, okay? So you see in 10 years how fast this water level is depleting. And also not only that, the water that we get at 100 feet is not drinkable. It's like really polluted, okay? So the situation is, is getting bad day by day. Okay, the resources are basically reducing, the population is growing, the demand is growing, and with this increasing demand, it's creating a lot of politics, and at the same time it's creating a lot of violence. I remember watching in the news that in some part of Maharashtra, like, a water tanker comes every day to fulfill the needs of people, but there's a fight among people. Why? Because everybody needs water, right? So you see, we have been to a situation where we are like getting so many fantastic technologies. Okay, mobile phones are like changing every 6 months, but a major portion of our population, they do not have access to clean water. It's a very alarming situation. People are working, there are many scientists which are working, but we need more efficient solutions on the ground. Okay, otherwise there is no any point that you have like so many wonderful technologies with you, but at the same time you lack for the basic things. Okay, so wastewater treatment is becomes very important. Okay, because we have water. Okay, but it has a lot of solid, liquid, or gas materials which are unwanted, unvalued, and discharged by us actually. Okay, so what we call waste. So this waste, it gets dissolved in water. Okay, so it converts a clean water to wastewater. Okay, so if we could kind of treat this wastewater, so we can get some water, and that water can be used to fulfill the needs of some part of the population. Okay, uh, so this is a context of the work which basically we are doing, that 1 of 8 person in the world, you see how bad this situation is, they lack access to safe water. Every year millions of people die because of these water related diseases. Okay, in the developing part of world, millions of people, I mean, and mainly it's like kids and women. Every year there are millions of people, they are affected by diseases related to pollution in water, fluorosis and arsenicosis. These are two very big problems. Many people, those who are living in rural areas, they do not have access to safe water. Okay, people living in let's say the villages in the slums, they have to pay a lot of money to receive water. Okay, and because of like if people are basically having diseases, if people are not healthy, it in some way it also affects the economy. Okay, so every year, like we get like a lot of loss to our economy because of these waterborne diseases. Okay, what the United Nations say, that all people, whatever their stage of development and their social and economic conditions is, they have the right to have access to an adequate supply of safe drinking water. Okay, but we are far from this situation. Okay, not everybody has supply of safe drinking water. If you look at this picture on your screen, it tells you how bad this situation is going to be in 2025. Okay, so there are countries which are actually in your what we say, water stressed and water scarce countries, the one which is like slightly orange color. Okay, so like many African countries, even in 2000 they were in water stressed and water scarce countries. India is like going to be additional water stressed and water scarce countries by 2025. I mean, the way the situation is basically at our places, I think we are basically reaching to that stage where many part of our where people in many part of our country will not have access to safe and drinkable water. Okay, with this growing population, when with this growth in demand, because the resource is limited, and this issue makes the wastewater treatment and an important technology. Okay, I mean, why, if you could develop like more technologies which are able to uh, treat this water. Okay, now this actually tells you what are some common water pollutants. Okay, so some microbials, some toxic metal ions, fluoride, nitrate, salinity, etc., etc., etc. Okay, so the question here is, how can we address the challenges with the advancements in the nanotechnology? Okay, and mm, we can actually develop different kind of materials, we can develop different kind of tools with the help of nanotechnology, and they will be able to help in the wastewater treatment. Okay. There is a concept of photocatalysis you might have heard. Okay, so what is photocatalysis is, it's a chemical transformation of a chemical reaction in the presence of light and photocatalyst. Okay, they can be of different types. And what actually we can do, so actually titanium dioxide is a very important nanomaterial. Okay, so what actually titanium dioxide it does, just look at this scheme. Okay, so let's say if you have water in which there are some organic pollutants are present. Okay, so you have titanium dioxide. If you, that the band gap of titanium dioxide is 3.2 electron volts, so it absorbs light in the ultraviolet region. Okay, so if you shine some ultraviolet light on this TiO2, so basically an electron goes from this conduction band to valence band, and the conduction band, so the electron actually it gets promoted to conduction band, and there is a hole generated here in the valence band. And then what happens, this electron actually, so this is actually the chemical reaction which follows. I will not go into the details. Okay, and at the end what does, there is some oxidation and some reduction, and they basically convert an organic pollutant to water and CO2 and some other non-toxic materials. Okay, so this photocatalysis is one of the way to basically treat wastewater. Okay, so now what is the challenge here? The challenge here is, as I said, its band gap is 3.2 electron volts, so it only involves ultraviolet light. Okay, the light with wavelengths less than 400 nanometers. So what actually we do, we develop some materials which have smaller band gaps. So small band gaps means less amount of energy. Less amount of energy means larger wavelengths, and that means the wavelength in visible region. Okay, so if you modify TiO2, if you make some nano composites, if you add like some other materials to TiO2, and you are able to reduce the band gap of TiO2, so there we can also use the visible light for the degradation of these organic pollutants. Okay, so TiO2 actually is a very important material. It is being used in a lot of things. Okay, like for example, you see a lot of environmental application. It is used in air purification for, you know, changing the order of the room. It is, as I showed you, it is used in water purification for the degradation of these organic pollutants. It is also used in the side mirror of your car. There is a coating of TiO2. Okay, in curtains, wallpapers, in agriculture, in medical, like in different kind of treatments, even as a coating of, you know, some many medicines. In energy conversion, you know, in solar cell, TiO2 is like very prominently it is being used. Even for the production of hydrogen, hydrogen is known as a clean fuel. TiO2 has found, like, you know, great application and numerically. Okay, so TiO2 is like a, I would say, like a wonder material which is basically being used in a lot of applications. Even the application of TiO2 has reached to industrial scale also. Okay, there are many other materials which are basically being used from the laboratory to the industry. Okay, TiO2 is one of the important ones. What we have done, actually, we work with TiO2, we work with some other perovskite materials, we work with other metal nanoparticles. So this is just to show you what we have done in a very simple way to degrade these organic pollutants. We have taken a filter paper, okay, and the same kind of treatment we have done on other substrate also, okay, and we have deposited silver nanoparticles on it. Okay, so you see these small spheres, they are basically silver nanoparticles. Okay, and these are the characterization. Okay, this is the same of the filter paper which shows like fibers, and these are the transmission electron microscopy measurements of these spherical nanoparticles. Okay, so what actually we have done, we have first we have taken a filter paper, we have deposited silver nanoparticles, and now what we do, actually, you take this, okay, and you take some water and you add, let's say, a pollutant. So you can, like, nitrophenol is a very important pollutants. Okay, uh, there are different kind of dyes, methyl orange, methyl red, rhodamine B, and others. Okay, so you take this filter paper which has silver nanoparticles on it, they are attached through a chemical process, and you just dip, you know, that filter paper to this polluted water. Okay, and if you look at this graph on this right hand side, so it says that like in 12 minutes it converts this nitrophenol to aminophenol. Okay, so aminophenol is not toxic. Okay, so in less than 15 minutes, this the filter paper, which has silver nanoparticles on it, it is able to transform this 4-nitrophenol to 4-aminophenol. Okay, I think okay, yeah. So here you see like we have did the same experiment on methyl orange. Methyl orange is a dye. Okay, so in like 20 minutes or so, it has converted this complete methyl orange to a methyl orange is basically a hazardous thing in water. Okay, so it has degraded that into CO2, H2, and other some non-toxic compounds. Okay, so this is the kind of research which I've been doing. Okay, so develop these materials which can be used for degradation of these organic pollutants. That was the first part. Okay, in the second part, what I'm actually working on is I'm basically using these magnetic nanoparticles. Okay, and I'm trying to develop a device. Okay, which is able to purify the water. Okay, so you might ask, okay, I mean, we already have an RO. Why do we need another one? Okay, so I'll briefly explain what are the issues with the RO, what are the issues that should be addressed, and how we are planning to address that issue. Okay. So just to tell you a very nice story. Okay, Qatar, we all know about Qatar. Okay, Qatar is a country in Middle East. Okay, so this is their situation in 1940. Their population was 11,000, and they just was living a nomadic life. There was very little education. There was almost no water, no energy, no hospital in Qatar in 1940. Okay, and if you look at the data, Qatar was the country in 1940 which was consuming the least amount of water per person in the world. Okay, the water consumption per person was the least in 1940 in Qatar. Okay, now if you look, actually this picture I got from 2016 or 17. So the population, it moved from 11,000 to 1.7 million. And you look, how the Qatar has transformed the two pictures. Okay, their economic growth was like more than 15%. The lifespan went from 50 to 78, and the water consumption per person went to 430 liters, per person per capita per year. Actually, okay, it actually I looked at the data and found this is the maximum water consumption. Okay, so Qatar is a country which went from the least consumption of water per person to the most amount of water consumption per person per year. And how could they do that? They did this desalination of seawater. Okay, so you remember I told you in the beginning that 97% of our water is in the ocean. Okay, but it is useless for us. It's not really useless if you have a lot of money. Okay, what you can do, you can use this process of desalination and you can convert that seawater to drinking water, but it's a very, very expensive process. Okay, we are not that rich. I mean, these countries in the Middle East are rich. You see, everything is related. They are rich because they have oil. Okay, why? Because oil is used everywhere. Okay, so they are basically selling that oil, they are basically generating a lot of money, and that money they are basically using to for these kind of super expensive process. Okay, but since we do not have that much of oil and also we do not have that much of money, these processes are not affordable for us. Okay, so what can we do? Okay, so we have a reverse osmosis system. Okay, so just to briefly explain you how does the reverse osmosis system work. What is osmosis? If you look at this tube, so a tube has there is a kind of membrane in between. Okay, and there are solvents. Okay, so in one part there are less it is less concentrated, and another part it is more concentrated. Okay, so normally the natural tendency of water is to move from a less concentrated part to high concentrated part. Okay, this is what physics allows. Okay, to move from less concentrated solution to a more concentrated one. Okay, What an RO system does, this is a natural tendency that it applies a lot of external pressure. Okay, so you have like a water which is like highly concentrated with different kind of salts and all. You remember you said the TDS on that one. So basically this is from where this TDS comes. Okay, so you apply a lot of pressure on this side. It is a highly concentrated solution, and you force this water to go on this one. Okay, and what this membrane does, it filters this one. Okay, these salts and other things, unwanted things, this membrane does the filtering. So on this side, on the left hand side, now you receive the fresh water, but there is a problem on this one. Okay, you are forcing your very highly concentrated water to go through a semi-permeable membrane. That's the first problem. You're applying a lot of pressure, so you need electricity, okay, to apply some pressure. That's first problem. Second, since you're using a membrane, so like it's all the time it is under stress, your membrane. Okay, so there is a chance that okay, your membrane will foul at some point, which happens actually very often. Okay, so you have to change that membrane every now and then. There is another problem. You all might have noticed that with our RO there comes a pipe, and all the time like a lot of water keeps on coming out from that pipe. So what actually the role of that pipe is, just to give you a number, for every liter of water that we feed to an RO system, we get like almost 350 ml of drinkable water. Okay, so that 650 to 700 ml of water, it gets wasted again. Okay, and why does it get wasted? Because when you are applying a lot of pressure and you are sending clean water on the other side, so on your one side, the concentration of this these solutes, it keeps on increasing. Okay, and at some point it becomes so much that your membrane cannot filter it. Okay, so it uses that pipe and it rejects that feed water. Okay, so you are getting pure water, but at the same time, for every 1/4 liter of water, you're wasting 3/4 liter of water. Okay, so these are like certain challenges before an RO system. So it's good that you get a highly pure water, but at the same time there is wastage of water. Almost 3/4 of the water gets wastage. You need energy because you want to apply pressure on it. The process is slow. And if you talk about efficiency in terms of both energy and the yield of pure water, this process is like really less efficient. Okay, the question is, do we have a solution to it? The answer is both yes or no. Yes, concept wise yes, product wise no. So actually I'm working on that solution, and what that solution is the forward osmosis. Okay, so as I showed you in the very beginning, that what this natural tendency of this water is, if I go back, the natural tendency of this water is to move from this less concentrated part to this high concentrated part. Okay, an RO system does the opposite. It forces this one to move through this membrane. Okay, but what if I allow my water to move naturally? Okay, how can we make that happen? We can, this is where these magnetic nanoparticles they come. Okay, so we can, if we can develop some kind of materials which are basically able to increase the concentration of these solutes, so water will naturally flow from this wastewater to the water having high solute concentration. And if we could filter those solutes in some way, so I'll briefly show you how could we do it. Okay, so this will first make this process a low energy process and energy efficient, and plus in this case all the water will be converted, all the wastewater will be converted to pure water. Okay, because there is no wastage in this process. So to get that done, what we use magnetic nanomaterials, and I'll show you. So this is a kind of scheme which we use to prepare these magnetic nanomaterials. We put some kind of coating on it. We functionalize it with some kind of polymers, and there is a reason for that. This is the work which we have done. I will not go into the detail. These are the values of the osmotic pressures that we have been able to generate. Okay, so here comes the idea. Okay, so you have these magnetic nanoparticles. You apply some kind of coating on it. Okay, and there is a temperature. Okay, we call it lower critical solution temperature. Okay, so when your T is greater than, they like stay far, and when your T is smaller than that lower critical solution temperature, they come together. Okay, so this is the concept that we use for the separation. Okay, so you look at this diagram. Okay, so as I said, what we have these magnetic nanoparticles, the gray one with red color capping on it. So if we add on one side of this water, so what will happen? The concentration of solute on this side will increase, and the water will naturally flow from the right to left side. Okay, and then what we can use a magnet to bring those nanoparticles together. Okay, and then this water which we are left with can be used as a basically a drinking water. Okay, so on the left hand side, what you see is a concept diagram of this kind of setup on which we are working. Okay, so our proposed work is to develop some new kind of cross solutes, which is basically surface functionalized magnetic nanoparticles. Okay, and then we put these nanoparticles into the solution. We increase basically the osmotic pressure. Okay, the water will naturally flow, and in this case, what we expect that all the wastewater will be converted to the drinkable water. Okay, so we have actually also got a project from Department of Science and Technology to work on this idea. We are working on it, and let's hope that in future we come up with let's say a portable solution for this problem. Okay, so this was the work which I was doing related to the water thing. Okay, now I will briefly, I think I have some more minutes left, so I'll briefly tell you about what is the situation about this green technology and environmental sustainability in India. Okay, so I will not go into very details. I'll just discuss some. First, the concept of renewable energy, and then I will discuss the concept of biofuels. Okay, so energy, is, we all agree that it is one of the most important things that we need to live our life. Okay, recently there has been a huge increase in the demand. Okay, because with the increase in the population, with the increase in the demand is increasing. Okay, and India is also like becoming like one of the biggest consumer. Okay, so the demand in the use of energy is also basically increasing the pollution. It also bringing new kind of challenges. It also basically harming our environment. Okay, so what actually we should be doing is we should be thinking about how we can reduce our dependency on the fossil fuels, and how we can produce energy from sources which basically does the very little or less damage to our environment. Okay, so there comes the concept of renewable energy. Okay, why we call it renewable? Because the sources that we use to create this energy, basically they renew and replenish themselves in a reasonably short period of time. Okay, this doesn't happen with the fossil fuels. Okay, because the fossils have taken actually, I don't know, maybe millions of years to be converted to the fuel. Okay, so I mean they are renewable on a million years of time scale. Okay, which in principle we do not call them renewable. Okay, but look at the sun or water or wind and other things which can be used to convert this energy. Okay, so they are basically known as what, renewable. Okay, because they can renew themselves. Okay, so these are certain source. Solar is one, hydro is another one, wind, biomass, geothermal, and tidal techniques which can be used to get actually energy. Okay, so as I said, like the sources can renew themselves. Okay, so actually we are not basically depending on, let's say, a foreign government, and that's one of the very important aspect actually, that we basically will reduce our dependency on different countries. Every day we just hear that the petrol prices are going up and diesel prices are going up, and we do not have any control on us. Why we do not have control? Because we do not have the source with us. Okay, the source is lying with another government. Okay, so it's if a different government is basically creating some kind of false shortage, the prices will automatically go up. Okay, so if we could manage to produce energy from these renewable sources, we immediately reduce our dependency on the fuel, and as well as our dependency on the foreign governments. Okay, there is also environmental benefit to that. Okay, because it's clean, so no greenhouse, so no carbon emissions, and plus there is no depletion of natural resources. Okay, so we basically minimize the waste which we basically throw in our environment. Okay, they're reliable. Okay, they're reliable because there are less disputes, there are less political conflicts. They are basically it all depends on you, because you also have access to those things. You also have access to sun, you also have access to wind, you also have access to water. Okay, so let's say any dispute in one of the geographical area will not disrupt your energy supplies. Okay, so there are there are also benefits, because they're not cheaper right now, but if we could manage to do this production on a larger scale, if we could manage to manufacture the things on our own, many kinds of jobs will be created, and many kind of we will have our own dependency. So in one way, it will be economically beneficial for us. Okay, and automatically, like, the energy prices will be more stable. Okay, so, well, everything has its disadvantages too. Okay, reliability is a very important parameter here. Okay, like, for example, I don't know, maybe some of you have these solar panels at your houses, installed at your houses. Okay, so let's say if you don't have sun, right, so you don't get energy, right? So if weather goes like absurd for a certain period of time, so that will actually disrupt the energy supply. So we need to find an alternative. Okay, what can we do in that case when our these systems are not able to supply energy to us? Okay, so that's one issue. Okay, also, since these things are in a very, let's say, young stage, so it's very difficult to generate things in a large quantity. Okay, also, as I said in the very beginning, the initial investment cost is very high. Okay, because the infrastructure doesn't exist. We have to create this infrastructure. Okay, so to create this infrastructure, we have to invest a lot of money. Okay, as well as since everything has to be done from the scratch, it also involve a lot of lands. Okay, so these are some challenges before the this large scale use of these renewable energy in India. Okay, the good thing is in India we have a Ministry of New and Renewable Energy. Okay, and it was the first, India was the first country to set up a Ministry of Non-Conventional Energy Resources. Okay, so we are very serious about this one. Okay, even we have a program we call IREDA, Indian Renewable Energy Development Agency, which basically promote and develop this financial support for renewable energy and energy efficiency. Okay, what else the government has done? Because we are talking about Indian context. They have developed a national clean energy fund. Okay, so what this clean energy fund does, it invests actually a lot of money for the development and installation and other like ventures which are basically going to produce this clean energy. Okay, also there are like renewable energy certificates. It's market-based instruments. Okay, for the production of renewable energy by generators. There are also off-grid power programs. There is green energy corridor. Okay, so Indian government is very, very serious about it. Okay, so if you look at this left-hand side diagram, so actually wind power is basically the largest one which is being used to generate this renewable energy. Solar power power is in comparison to wind, the solar power is a very, let's say, smaller portion of energy which is producing. Okay, this actually tells you where do we stand in comparison to other countries. Okay, so this is a diagram from 2019 which tells you that what is the status of top end countries. Top end countries, 8 countries for the installation of these solar capacities. Okay, so in 2019, China, if you look at these, China is basically generating 207.7 gigawatt. Next is US by a factor of 3 smaller. And we are at 1, 2, 3, 4, 5th, okay, place in terms of, let's say, in comparison to other countries. Okay, I found that the data from 2021 and the total installed capacity of India was only 47.7 gigawatt on 31st October 2021. Okay, so a lot of work has to be done. Okay, Rajasthan actually is playing a very important role in that one. Okay, it is one of the India's most solar developed state. Okay, with its total photovoltaic capacity was like in 2018 it was 2,289 megawatt. Okay, there are many solar plants. There is also, I think, the biggest solar park of the world is Bhadla Solar Park. Anybody have heard about the name? It's in the Bikaner district. Okay, yeah, I think it's in Bikaner district. There is also a tower type solar plant in the Bikaner district. So this area of this Bikaner, Jodhpur, Jaisalmer, it has a lot of solar plants installed over there. Okay. In March 2019, the lowest tariff in India was rupees 2.48 kilowatt hour for installing the 750 megawatt solar power plants in the state. So Rajasthan is doing very good when it's about the installation of these solar plants, okay, and generation of electricity. The next one is the wind power, okay. So recently the wind power generation capacity has increased. In February 21, we were like this capacity was 38.789, which was 4th largest installed wind power capacity in the world. Okay, so we are doing very good when it's about the generation of energy with the wind power. Okay, and in that list, if I look at, like as I said, in solar, Rajasthan is doing very good. In the case of this wind power, Tamil Nadu tops the list of the states with the largest installed wind power generation capacity in the country. Okay, it's in 2018 it was around 8,631 megawatt, and the generation was almost like 30% only from the state of Tamil Nadu. Okay, Rajasthan has the 5th largest installed wind power generation capacity. Okay, there are also issues, because these are relatively new things. Okay, so though they are like progressing, but at the same time certain issues come, like for example, if I talk about this wind power, so the government announced that by 2021 we should be able to install 175 gigawatt, but we could only reach to, like, I don't know, maybe like 60 or 70 gigawatt. And one of the reasons, because we shifted our focus from the wind power to solar power. Okay, so over the last few years, this policy, the government policy has been such that the solar power is getting more importance in comparison to the wind power. Okay, and what if you look at the data from the Ministry of New and Renewable Energy, these wind powers basically of almost 13 gigawatts, they are in pipeline. Okay, they should have been completed by now, but unfortunately, because of I mean, it's a big country and there are like many issues and many challenges. Okay, so unfortunately we are not approaching to the target that we fixed. Okay, so these are the current situation about solar and the wind energy in India. Okay, the research is going on. The government is also like making different kind of policies, different kind of development programs are being organized in order to get a better generation of these renewable energies. Okay, there are challenges, and obviously government is looking at that one, okay, because these are things which cannot be taken care by an individual, okay. The government has to come into and play a very important role into it, okay. Next comes the biofuels for the sustainable development, okay. So what, I mean, why biofuels, okay. So if you just look at the energy demands, so almost 60% of power that we generate, it comes from the fossil fuels, okay. And as we know that they were generated after millions of years of decompositions, once they are gone, okay, the situation will become disastrous because we will need energy, okay. That's one point. And second point, their environmental consequences are, very, very dangerous, okay. I mean, they have produces these greenhouse effects, CO2 emissions and all, and it's all because of that we are having a bad environment, okay. So biofuels have now emerged as an important alternative to these conventional fuels, okay. It also belongs to a renewable category of fuels. It is environmentally beneficial, economically competitive, and it can be produced in large quantities, okay. So biofuels give you, like a hope that we will be able to, well, not immediately, but in near future, we will be able to decrease our dependency on the fossil fuels, and we'll be able to generate these more and more biofuels, okay. So by definition, what these biofuels are, they're like any hydrocarbon fuels which are obtained from organic matter in a short span of time. Like you take some days, you take some weeks or some months, and like after some biological process, you get something which can be used as a fuel, okay. They can be solid, they can be liquid, or they can be gas also. So there are different examples. I will not go into the detail. What I'll focus on, I'll talk about these liquid fuels, okay. So then liquid part, this bioethanol, okay. So you all know about they're obtained by the fermentation reaction of microorganism over sugar, and they're like first generation bioethanol and second generation bioethanol, and the second one is a biodiesel, okay. So biodiesel has gained a lot of popularity in the recent times, okay. So they can also be used as neat, or they can also be used in mixture with some kind of diesel in that one, okay. Europe is the largest consumer of biodiesel, okay. So it's basically it's a substitute of diesel, okay. Diesel has created a lot of pollution, I mean, yeah. So the good thing is, uh, even the same kind of engine which is used for diesels, with slight modification they can be used for biodiesels, okay. So biodiesels are actually basically gaining a lot of importance, okay. So if you just pure biodiesel alone, you can find like there is a reduction of 60% in the emission of these polluted gases, okay. So even the what this World Energy Organization says, that this ozone forming potential of this biodiesel is about 50% less in comparison to the diesel, okay. This cancer causing potential of this biodiesel is about 90% less, okay. So it's from an health point of view, from environment point of view, from economic point of view, this biodiesel is really, really useful, okay. So you can blend it with diesel, you can use it alone also, okay. There are also gaseous, biogas, syngas, you all know about it, so I will not talk about that. I will just briefly tell you that what is the role this biodiesel is basically playing. This is a schematic which tells you that how you can use an oil crop, and from that oil crop, by using the process of transesterification, okay, this is the name of the process, we can use a biodiesel which can be used to run the vehicles, okay. So this is the schematic for that, what we call this the biodiesel cycle, okay. Now, what is the role of and the challenges of this biodiesel for this Indian transport sector? Okay, the first few challenges are there is a very let's say the availability is is one of the issue of these things. Okay, This shows you that how the different kind of vehicles, because the number of vehicles are growing day by day. Okay, so even though we have fossil fuels available in, let's say, different countries, the demand is growing. Okay, the prices are going up. Okay? So we need to look for alternatives, and these alternatives are these biofuels. Okay, uh, so what we should be doing actually. Okay, so there is there are like approaches. Okay, first what we should avoid. Okay, we should reduce traveling and other distances by we should actually use what we call the private vehicles. Okay, we should be avoiding that. Okay, like for example, you might have listened in the news that what Delhi government is asking to Delhites is that at least one day you don't use your private vehicle. Okay, you take the common mode of transport. You take the bus, you take the metro. Okay, so we should avoid using private vehicles until and unless necessary. Okay, that will immediately reduce the pollution as well as this use of fuels. Okay, if it is possible to take, let's say, a bus, we should go with a bus. If it is possible to take let's say a metro, we should take metro. Okay, we should, when we're going to purchase, we should purchase something, let's say a hybrid vehicle. Okay, now we have these CNG cars. We slowly the electric cars are also coming to the market. We already have e-rickshaw, okay, which basically runs on battery. Fuels, we should actually try to find some cleaner fuels. Okay, we should use environmentally friendly modes of traveling and walking. Okay, we improve our energy efficiency, we improve the systems that we use to convert energy, and we use this I remember one very funny thing. Okay, Jaipur is very good in that one, but when this new motor vehicle policies were announced, there were queues in front of these pollution testing centers. Why? Because people are not in the habit of getting these tests done. Okay, so it doesn't directly impact you, but if your vehicle is producing a lot of pollution, basically it's harming environment, and then it is coming back to you. Okay, so we should be a little more responsible. Okay, because it's our actions which can improve the environment. Okay, so this approach of avoid, shift, and improve is what basically in the transport system will basically help India to become a greener, Indian transport sector. Okay, so this biodiesel we are talking about, it basically consists of a mixture of different kind of esters, which basically derived from this trans esterification. So you can use a vegetable oil, or you can use some other kind of oil to get this done. Okay, biomass is being used a lot for the production of these biofuels. Okay, in India we use a lot of diesel vehicles. Okay, it's 4 times petrol, and that's why the government actually started looking for these alternatives, and they made a policy in 2009. They made a policy on biofuels, national policy on biofuels, and that policy has proposed that we should be blending 20% of biodiesel in high-speed diesels. The idea was that in 2017, but in some places we have it, in some places we don't. And what the plan of the government is, by doing this, by blending biodiesel to these diesel and supply these, we should be able to reduce our import of crude oil by 10% in 2022. Okay. Then government has made like an intended nationally determined contribution, which basically is looking for how we can cut down the emission. Okay, the emissions which basically happens from our engines. These are ambitious things, but until and unless we take some extreme steps, things won't improve. Okay. There is a decision by Union Cabinet for these national policy on biofuels. Like as I said, to 20% blending of biodiesel and ethanol in high-speed diesels. There is also different other kind of policies to improve the transport sectors. Okay. in spite of all the good things that I'm talking to you, the biodiesel industry is in a very it's a very naive stage. It's the very beginning, okay? And the reason is the lack of sufficient infrastructure and poor institutional setup, okay? It's because all these policies and all the things that the government has made, since they do not develop infrastructure, they fail, okay? They set up some targets, but the targets cannot be achieved on their own, okay? We need some people to work for it. We need a setup to so that which helped us to achieve that target, okay? But unfortunately, since we do not have that kind of setup, all these policies, they fail, okay? There are 1,000 crores of investment lying down just because there is no commercial market, okay? uh, Government is doing certain things, but what they should do is they should work. This is actually the policy and uh, support framework which is required if we want uh, this supply chain for promoting biodiesel industry. So input, production, processing, marketing, and use. Okay, so these are certain policies proposed by the economists. Okay. Uh, Now, I would like to conclude that what this green technology, how this green technology is actually making a difference in our life. Okay, so I will not go into very detail. I will briefly tell you. I talked to you about water purification, that how we can treat water by using these technologies, by developing some new kind of technologies, and we can treat the wastewater. That is one. Recycling and waste management is another one. Okay, so we develop some new advancements, some new technologies. Those are helping in recycling of the waste materials. We develop some buildings which are self-sustained, self-sufficient. We generate energy from waves. We generate energy from waste. We generate energy from actually renewable items. Okay, so they are actually energy. Energy and water, as I said, are the two most important sectors where these technologies have a lot of work to do, and basically they will affect actually the rest of the things. Okay, vehicles, the transport sector. Okay, we need to work more on these fuels. We need to work more on the engines which produce less and less pollution, the different kind of energies. There is another concept which you might have heard is vertical gardening and farming. Okay, so what this vertical farming is basically an eco-friendly technology, and it has the potential to solve our food production problems. Why? Because you go vertically rather than horizontally. Okay, so use the space that is access to you, but you also use the sky which is accessible to you. Okay, so at many places this what the concept of vertical farming has become started. They use uh, less water, and the production is getting more and more in many parts of world like Canada, Singapore, UK, and US. These techniques are basically finding applications. Okay, so to conclude what we talked about. We talked about what this green technology is, what this environment is, and how this green technology be helpful to give us a better environment. Okay, so I'll just briefly tell you about what are the pros, and not actually all the. It's not like green technology will solve everything. Okay, but there are some pros and some cons also. Okay, so as I said, it's like an energy efficient method. It will reduce your global warming. It will reduce different kind of pollutions. It will save the natural resources. It will allow feeding of more and more people on the global scale. It will bring new solutions for the energy related issues. It will make the things better. It will make a better environment. But what are the challenges before this green technology things? Okay, so the first thing, as I'm saying it from the very beginning, that R&D cost is very high. Okay, the implementation cost is very high. It's still immature. There are not very well informed people in that area. We need more and more people who can who are familiar with these kind of techniques. So implementation. So the less let's say experienced people we have, the more time it will take in its implementation, the cost will be more and more. Okay. And also it's not getting popular. Okay. Despite there are, from the government side, there are many, let's say, tax benefits. There are many, let's say, people are getting subsidized solar panels. Not everybody is going to install a solar panel in their house, and that's one of the reasons. Okay. In the end, not everything that is labeled as green is actually green. Okay. uh, to talk about this, I've taken help from different kind of books, different kind of internet materials, my own published and unpublished work. With all this, I think I am done, and thank you very much for being so patient for listening.